All right, seventh grade science students, day 3 of the egg experiment. So let's go forward with this. Of course, we're going to do some measuring. You guys are going to take down some data. You guys are going to write another hypothesis, a couple of descriptions. Before we get to that, though, I want to go through a little bit more in that background page. And that second paragraph talks about two things, diffusion and osmosis. And I'll tell you right now that you're going to see some similarities in those two because basically they're the same thing. And it says diffusion is the movement of molecules from an area of high concentration, that's where there's a lot of molecules, to an area of low concentration, that's where there aren't very many molecules, right? Osmosis, it says the process by which water molecules pass through a membrane from an area of high concentration to an area of low concentration. So the difference is osmosis is diffusion, uh, but diffusion isn't necessarily osmosis. Osmosis is only referring to water molecules, where diffusion could be oxygen, right? Or CO2, or it could be hydrogen, or it could be any number of other things, any other molecules, right? Osmosis strictly refers to water. So there's the difference. But it's basically the same process. An area of high concentration of molecules going to an area of low concentration of molecules. And it's not a magical thing like I talked about in the last video. It's really a physics thing. So the molecules want to even themselves out on both sides of the membrane, whatever that membrane is. In this case, it's the egg membrane, and those water molecules want to even themselves out on both sides of the membrane. So when that shell was dissolved, right, the concentration of water in a raw egg is not that high. I know it's kind of gooey, right? It's kind of seems somewhat liquidy, but I would guess it's probably no more than 25%, maybe 30%. Let's look at this slide here where you've been taking your data, right? And it says concentration of water in this top box here on the left side. Vinegar is 90% water. So once the shell was dissolved away and the membrane was exposed, and you have a very low concentration of water inside the egg and a high concentration of water outside the egg in the vinegar, it's physics. The water molecules want to pass through that membrane and even out the concentration on both sides of the membrane. That's why the water passes through into the egg. So the process that's happening there is osmosis, right? Specifically osmosis because it's dealing with water concentrations, right? We could also say it's diffusion because diffusion could be water, could be oxygen, could be CO2, could be other things. But specifically because it's water, we call it osmosis. All right, so for day 3, we're pouring off the syrup. We're going to use our data table, collect the measurements, placing the egg in the cup. And it says use distilled water. I'm just using some purified water. And then for some dramatic effect, add 1 or 2 drops of food coloring. And so we'll see how that turns out. Okay, so look at that. Egg looks a little different today, doesn't it? A little more deflated looking, not so much like a full water balloon, maybe one that's losing water. I like to do this at this stage of the experiment. Pour off the water slowly so that you guys can see this. And this is where I kind of had some problems with my video. Hopefully it's smoothed out. But while I'm narrating it here, it doesn't look so good. It looks kind of choppy. But you can see that it's more watery there. The stuff I poured off the top, what the egg is sitting in is still kind of thick and viscous. So the water kind of that looks like maybe left the egg. It was less dense. Here's me pulling the egg out of that, what was left of that syrup. I couldn't have done that yesterday. Grabbed the egg by the membrane there. All right, so let's get a mass. Here's another thing, didn't happen yesterday. It didn't bounce. Doesn't bounce today. Yesterday was bouncing nicely. You can see that yolk pretty nicely too. Kind of just saggy, floppy, way different than yesterday. Right. All right, so gotta get a mass. Gotta turn on the scale first, and it's at 43 grams, guys. That's a huge loss of mass. All right, so let's record that mass. 43 grams. We're going to put it right here. Mass after 24 hours in the corn syrup, 43 grams. And we'll also put it right here because it's the beginning mass as we're starting uh, the portion with water. There we go. Okay, so now we're doing the circumference, and it's a little trickier today. Egg's not as firm as it was yesterday, so it's kind of hard to get an accurate estimate of the circumference, but I'm estimating as well as I can. Put that string up with a ruler, and I know I'm not zoomed in on the numbers as well, but it is at 12.5. Okay, now so let's record the circumference, and that was 12.5 centimeters. We're going to put that right here, circumference after 24 hours in the corn syrup. Paste that in there. And then we're also going to put it in this column, beginning circumference with the water. Paste that in there, 12.5. Let me stretch that out a little. There we go. Got our data collected. Take a couple of minutes or a minute to put that data in. Start thinking about how you want to draw those arrows too, guys. How are we drawing those arrows today? Okay, so now we're going to put it in the cup. I've got the glass cup back again, and we're using that purified water. I'm going to cover the egg, and when I was videotaping this, I totally forgot about the food coloring. But right after I finished this little segment, I can assure you that I did add the couple of drops of blue food coloring. There we go. All right, guys, so let's look at our descriptions and our hypothesis today. Day 3, it says, describe how the egg is different today than it was yesterday when we placed it in the corn syrup. That should be fairly easy, right? A sentence or two describing, because it's a pretty big difference from when we removed it from the vinegar to the day when we removed it from the corn syrup. So think about that. And then, what process is causing the egg to first increase in mass and then decrease in mass? Now, if you were listening when I talked about those two concepts in the background in the second paragraph at the beginning here when we started this, I went into that quite a bit. You should be able to tell me what the process is. Really, it's just one word I'm looking for there. And then finally, the hypothesis, if I place the egg in water for 24 hours, then, guys, guess what? Water is 100% water. So the concentration of water is pretty high, going to be on the outside of that egg. So what do you think is going to happen? That should also help you with how you're going to put those arrows tomorrow, right? Okay, and speaking of arrows, let's put those in for today. So water molecules were going in the egg here. You had a very low concentration of water inside the egg. You remove the shell, the membrane's exposed, and the water molecules are able to pass through that membrane to go inside the egg. So then you had a high concentration of water in the egg. But then you placed it in corn syrup, which is only 10% water. So now you have a very low concentration outside the egg and a very high concentration in the egg. So how should we be putting our arrows? It's the opposite, isn't it? That water went back out of the egg. We saw that. All the water that was on top of that cup. So now we, the arrows outside, I'm going to increase the width of those arrows, and I'm going to make them black so they're a little more bold. Easy to do here on the top of your slides. There's another one. And we'll do one more. And now we're showing that the water molecules left the egg, right? Okay, day 4 will be on Monday. Can't wait.